Let's see how it looks. I see myself staring at my iPad.
And I get to hear you say that twice with about a 1 second delay.
How long was the delay?
It's about 1 second, maybe less.
Yeah, I think it's around 2
That's not
seconds.
bad at all. That's quite reasonable. Okay, let me quickly scroll through some slides and just make sure they look okay. 1 second. So all look good.
Milan, you might want to close the live stream on your end.
Indeed. Okay. Okay, I think I'm actually just gonna mute. You know what? I'm gonna just put some headphones in also. Can you guys hear me still?
Yes.
Yep.
Let's check one more time to see if there's a audio loop. Let's check one more time to see if there's a audio
There is an audio loop, but it shouldn't be coming from me though, because I don't have, my speakers aren't on.
Okay, one more try here.
Seems to be better.
Awesome.
Have we posted in Slack that we're live?
Yes.
All right. Hi, everybody. Welcome to PLMW at PLDI 2020. Normally, what this would say right under that is London, England, the United Kingdom, but we're actually just everywhere. We're virtual for the first time ever, and we're excited to have a lot of you joining us from around the world. So this is actually the 16th edition of the Programming Languages Mentoring Workshop. For those of you that have not participated in a PLMW before, we hold these 4 times a year, co-located with each of the 4 main SIGPlan conferences, so PLDI, POPL, UPSLA, and ICFP. This is the 16th one, and we're really excited about this edition. We have 6 amazing presentations for you and 2 panels. We're taking advantage of the virtual nature of PLMW to expand our, to sort of spread our wings a little bit and spread our talks and panels over 2 days to give everybody a little bit more time to breathe and interact. We have about 100 registered participants, plus as many people as want to join us on our live streams. If you are interested in the schedule of the events, you can go to the PLMW webpage and you'll see when exactly all of the different talks and panels are, who's presenting, who's part of the different panels, and links to the live streams for those different talks and panels. I want to thank my co-organizers for putting this together. It's been quite an effort to really rethink how we might do PLMW in this age of virtual workshops and conferences. So I want to thank Steve Chong, Nadia Polikarpova, Adrian Sampson, and I am Milan Kulkarni. So it's great to be here with all of you. It's great to be here with you virtually, even if we can't be with each other in person. I also want to thank a bunch of other people without whom this workshop wouldn't be possible. I want to thank our student volunteers, Linnea Ingmar, Baba Rehman, Tiancheng Xu, and Irene Yoon. They're really the ones that are going to help keep everything running smoothly throughout these events, throughout the couple of days of this event. I want to especially thank our speakers and panelists. Without these amazing speakers and panelists, a workshop like this wouldn't be possible. If we want to do a mentoring workshop, we need great mentors. And I think we've put together a fantastic slate of mentors to talk to you about technical advances in the field of programming language, as well as giving a lot of phenomenal advice and guidance about how to deal with, how to get started in research and how to do things like choose advisors, give talks, things like that. And I'm really excited for them to get to share their wisdom with all of us. I also want to thank our sponsors, Microsoft and Google. They are frequent, generous sponsors of these mentoring workshops, and we really thank them for all of the support that they give the programming languages community across all of these events. Okay, so this is the slide that normally we wouldn't give, but we're a virtual conference, and so it's important to talk about the virtual logistics of the conference. This is the first virtual conference, first virtual workshop of PLMW. So please bear with us as we work out how to manage a virtual mentoring workshop. I think it's especially challenging for mentoring workshops to go virtual because so much of the way these mentoring workshops work is by fostering interaction and network building between the participants and the speakers and the panelists and all the mentors that are here. And so it's going to be a little bit trickier as we go virtual. But please let us know what is working and what is not. Give us any feedback that you might have. So here's the way that this workshop is going to proceed. All of the talks and panels, including the talk you're watching right now, are going to be live streamed on YouTube. This is open to all. It's a link that anybody can access and anybody can view the live stream. Recorded sessions will be available if you miss a session. However, one of the things that we're going to work on and one of the things that we really are going to try to do in this workshop is have live interactive question and answer sessions, despite the fact that we're doing this remotely with all of these live streams. So we really hope that you'll join us live for each of these sessions. The way that we're going to do the question and answer is we're going to use a service called Slido, sli.do. It's just a website you can go to, and you can enter in an event code. So each of the 4 sessions of PLMW has a separate event code associated with it, and that's how we'll manage all of the Q&As for the sessions and panels. So if you have a question, you can enter it in on Slido. If you see a question that somebody else is asking that you are interested in hearing the answer to, you can upvote existing questions. And we, the moderators and student volunteers, will keep an eye on Slido and make sure that our speakers and panelists hear the right questions and can answer us. Our goal is to make this as close to an interactive experience as you might get in a real conference, and we hope that this will work out well. There are also comments enabled on the YouTube stream, so feel free to chat on the YouTube stream with each other. And those of you that are part of the PLMW Slack, you can also ask questions and have discussions there as well. So those are the logistics. You can find links to all of the live streams and to the question and answer sessions on the main PLMW program. So you'll see links for each of the sessions to the associated live stream as well as the associated Q&A session. Something that I want to remind everybody about is that PLMW, even in its virtual form, is still an ACM workshop, and we still follow ACM's policy against harassment. And so there's a link here, and the link is available from many ACM websites, including PLDI's. The gist of it, though, is that there's really 4 things that we are all responsible for as participants in this workshop. So one is that we should exercise consideration and respect in our speech and actions. We should refrain from demeaning, discriminatory, or harassing behavior in speech. We should be mindful of our surroundings and our fellow participants, especially be mindful that in a virtual setting, there's a lot of people that might see your comments and hear your thoughts that, in a face-to-face setting, you would actually see them. Please be mindful of the fact that when you're posting on YouTube or posting on Slido, that a lot of people will be able to see your talks and your thoughts and comments. Finally, alert community leaders if you notice a dangerous situation, someone in distress, or violations of this policy, even if they seem inconsequential. So with that, one thing that I do want to sort of highlight and emphasize, especially in the times that we're living in right now, this has always been PLMW's mission statement or creed, right? Our goal is to create a workshop that's designed to broaden the exposure of late-stage undergraduate students and early-stage graduate students to research and career opportunities in programming languages. That's the part we're familiar with. But there's another part of this mission statement that is equally important, which is that PLMW has always wanted to give a special focus to underrepresented groups in programming languages. And we've tried very hard to bring people from these underrepresented groups into the community and provide them with a nurturing environment. And so with that, I think it's important. We, the organizers of PLMW, felt that it was important that we make a statement on the events of the recent weeks. If you will permit me, I'd like to take a minute to read out a statement about the Programming Languages Mentoring Workshop and Black Lives Matter. So the last few weeks has seen an outpouring of anger, activism, and protest in North America and around the world in response to the killing of George Floyd in Minneapolis, coming close on the heels of the killings of Ahmaud Arbery in Georgia and Breonna Taylor in Louisville. We recognize that the angers surrounding issues of police violence and racial discrimination, especially anti-Black racism, did not emerge recently, but instead reflects conditions that have existed for decades. The events of this past month are just a flashpoint. Part of PLMW's mission is fostering diversity and inclusion in the programming languages community, and it has placed a special emphasis on reaching out to and mentoring students from underrepresented groups. The events of the past few weeks have been particularly stressful to minorities, and especially the Black members of our community. To make matters worse, all of this is happening in the shadow of the COVID-19 pandemic, whose effects have fallen disproportionately hard on the Black community and other minority groups, and when we are isolated from our usual support structures. We hope that the virtual network that we build during this workshop can bring some comfort and support. Amidst the life and death issues at the forefront of our minds, things such as formal semantics may feel silly or trivial. Nevertheless, we hope that the activities of this workshop can act as a tiny refuge. We, the organizers of PLMW, want the members of our community, especially the Black members, to know this. Black Lives Matter. Diversity of all kinds has always been PLMW's goal. It's also important that we recognize that Black students face unique forms of discrimination that other minorities do not have to deal with. PLMW and our community more broadly needs to evolve to address these systemic issues. A welcoming, inclusive, diverse environment that stands by the principles of anti-racism and provides space for all to thrive and breathe. We would like to bring our attendees' attention to a few initiatives that we hope can help. SIGPlan has established a committee called SIGPlan Cares. This group of distinguished senior researchers is available as a confidential resource for anyone who faces discrimination or harassment. In addition, we, the organizers of PLMW, want to offer individual mentoring to any student who is coping with issues of racism and discrimination, or who would like to have a one-on-one confidential discussion about other topics. This is a pilot program that we're putting in place that we hope to expand to provide sustained mentoring opportunities, even outside the confines of PLMW workshops. Please feel free to reach out to us at any time via Slack or email if you would like to talk privately. If you go to the PLMW website, you'll also see a link to a common email address that you can send an email to. That will send an email to all of the organizers, and we can work with you on finding an opportunity for one-on-one discussions. So just to reiterate, our commitment in the course of PLMW is that we're committed to providing individual mentoring to students who are coping with racism and discrimination. For example, if you've dealt with racism or discrimination in your academic life, or if you're concerned about finding an inclusive environment for graduate school, and you would like somebody to talk to, we're available. Please reach out via Slack or email if you would like to talk privately, and you can also address PLMW PLDI cares at googlegroups.com. So with that, I would like to welcome you to our first virtual PLMW. We have an amazing slate of talks and panels today and tomorrow. And I'm going to turn it over now to the session chair of our first session, Steve Chong from Harvard.
Great, thanks so much, Milind, and welcome everybody to the first session of PLMW PLDI 2020. In this session, we're going to be having two talks, a technical talk by Eran Yahav first, and then a mentoring talk by Ali Donaldson. As Milind mentioned, we want to make this very interactive, so we do have the Slido link. You can find the link to the Slido page on the YouTube page just underneath the video if you're not there already. We will be monitoring it throughout and relaying those questions onto the speakers, so please ask questions as they come up. Okay, so I'm delighted to welcome Eran Yahav. Eran is faculty at the Technion, which is where he also did his undergrad. Prior to that, he was at IBM TJ Watson Research Center, and just before that, he completed his PhD at Tel Aviv University. So Eran's research includes program analysis, program synthesis, and program verification. And Eran is a remarkably prolific researcher. So over the years, he's had a total of 14 papers at PLDIs, which I believe actually puts him in the top 5 most published authors at PLDI of all time, which is highly impressive. So I'm delighted to welcome Eran today, who's going to be talking with us about neural methods for programming language processing. So with that, I'll hand it over to Eran, and I'll interrupt and chime in relaying questions as we go along. Thanks.
All right, so thanks everybody. I'm Eran, and the first thing I should say is actually being a prolific writer in PLDI is mostly a function of being old. So having 14 papers in PLDI is not that uncommon if you just stick around long enough. So just that is to say, don't measure yourself by the number of PLDIs, but actually about the interesting results that you produce. And I hope to have you in the PL community for many years. All right, so I'm Eran, and this is my setup right now in this virtual PLMW. And what I want you to see is that I'm monitoring questions on Slido right here online. So please feel free to interject at any point. It would make the talk more interesting for you and for me as well. And I want to talk about neural methods in programming language processing. And as you probably know, neural methods, neural networks has made tremendous progress in recent years in areas like image processing, video processing, and others. So for example, I can take this image, give it to a neural network, and the neural network can automatically predict a caption that says that the person is riding a surfboard in the ocean. Neural networks can also synthesize realistically looking images of humans that do not exist, like the StyleGAN network from NVIDIA. And they can even compose pretty compelling So they can produce, compose pretty compelling jazz improvisations as well, as we saw from as we heard from the bebopnet. And the question is, what does it mean for us as PL researchers, as people who are actually working on the languages that we use to communicate between the human and the machine? And this is what I'd like to talk about today. And I'd like to start with a few examples just to give you a taste of the things that we would like our models to do. So let's take a few seconds to look at this simple Java program. My question to you, the audience, is what does this program do? And I'll give you 5 seconds, probably the delay of the live talk anyway. And if you look at the program, you will see that it is doing a lot of low-level stuff on arrays, like it's going over the indices, it is doing some assignment with like index -1, etc. But we can ask a neural model to describe what this program does. And in this case, the neural model will say, hey, this program performs the operation of reverse array with a really high confidence of 77%. And even the second prediction here, reverse, is quite compelling. Another example, let's look at this program here. And this program is a C# program this time. It reads text from a file, it replaces some string in a file, and it writes the file back. And again, let's try and understand what this program does. And we can ask the neural model, and the neural model can predict the caption that this program replaces a string in a text file, which is again a pretty good description of what happens in this piece of code. As the last kind of motivating example, let's look at this one. This is a partial program in which the yellow rectangle here denotes the missing piece, and we'd like the neural model to predict the code completion in this location, and we can invoke the neural model, and the neural model says, hey, the prediction here is stats I get path, and I'd like you to see that the prediction here is not just one token or one word. The prediction here is actually an expression that is syntactically legal and actually semantic legal as well. It is guaranteed to compile and guaranteed to do something sensible in this particular context. And we'll see several models that enable us to do these things. All right, so these are kind of the motivating example for this talk. And the talk itself is around the area of programming language processing, as we call it PLP, kind of as analogous to NLP, natural language processing. And this area is really the intersection of three things. It is clearly involving programming languages because everything in this area operates around programming languages. It is using techniques from machine learning to operate on programming language entities. And it is really also using a lot of natural language processing techniques per se, together with programming languages. So the idea here is not to use NLP techniques directly on code, treating code as text, although that is obviously possible as well, but rather to get inspiration and get some of the models from NLP and adjust them to the setting of programming languages. So we are really working on the intersection of these areas in which many interesting things are happening these days. And to train neural models on code, we need data. Obviously, our data is code. And luckily for us, there's tons and tons of code available out there. In open source, we have 100 million repositories on GitHub containing high quality code that we can learn from. We have millions of questions and answers on Stack Overflow, where many answers contain code, creating some connection between textual metadata and code snippets. We have millions and millions of applications on the Google Play Store, on Apple App Store. And if you look at executables at large, we have billions of executables out there that we can also learn from. This is tons and tons of data, mostly unlabeled, but it can really enable a lot of interesting tasks. And what we'd like to do as a title, we'd like to learn from all this code out there to make software development faster and smarter. And really, using all this data and using the models that I will show you, it is really an opportunity for us as researchers to completely change how we do things. We can use these models to change how we do software design. For example, the models can help us pick the right libraries or framework. We can use these models to do improve the way we handle deployment, help us with deployment scripts, help us diagnosing problems in production, etc. And we can also use them during the development process itself, doing code prediction, continuous code review, generating test cases, and stuff like that. So I will not touch on all of these, but I would like to show you a bunch of tasks in which these models could be used. And the idea of this talk is to be wide rather than deep. So I'm going to cover many, many use cases and many tasks and go dive deeper on one or two of them to give you some sense or intuition of how these things work. So we've been doing this for a long, long time now, for many years. There's a bunch of papers that you can look at later. Most of what I will show you is available as open source for you to play with, and the links are here. I will share the slides later. And I'm giving the talk, but this is really the work of many, many talented people over the years, my students who are listed here, and many collaborators as well. I will mostly talk about work, mention work by Uri Alon, and maybe a little bit by Shaked Brody and Noam Yefet. All right. So let's start. The first thing I'd like to maybe give you intuition for is why PLP, programming language processing, is not exactly like NLP and what are the differences, especially for the people here who are familiar with NLP. And so there's a little handy table here, which is really hand-wavy, but should give you some intuitive impression. So the first thing is that natural languages are ambiguous, and we're handling program languages which are really unambiguous. Natural languages are really sequential first. When you are reading a sentence, you are reading it in a particular order. Changing the order of the words often results with things that do not really make sense. Program languages are syntactic first. Parsing is deterministic. We have a parser. We can check if the program adheres to the program language syntax. We can do automatic operations on it, etc., etc. Natural languages understanding is difficult for a machine, whereas for program languages, clearly I can execute the program. So maybe I cannot really prove semantic properties, but at least I can run it and see what it does and assign meaning to it that way. Natural language, it's again difficult to verify meaning. You can have sentences like colorless green ideas sleep furiously, which sound great, but when you try to assign meaning to them, are not really sensible. And for program languages, some semantic properties can be trivially verified, even though it's expensive, some type checking and other things. And of course, non-trivial semantic properties are often undecidable, like the halting problem. Last thing, which is important when we're going to talk about code generation, is that natural languages are a bit more robust to mistakes. I can have some typos. I can do certain manipulations where the human can still understand the mutated entity. Whereas for a program language, the minute you start mutating characters in a program or just doing all sorts of local transformations, the program itself may no longer pass even parsing and may fail the machine. So how large small is the current field of PLP? I'm taking random, that's a good place to take questions. So how large small is the current field of PLP, and how does this compare with the amount of intersection between PLP and PL and NLP? So the short answer is that I have absolutely no idea. The longer answer is that this is growing. So we see more and more papers on applying machine learning techniques to code. I think there has been significant growth of this field in the last 3-4 years. So I don't know the numbers, but it seems to be growing nicely. And there's a reason for it, which is a lot of what we used to do using very sophisticated rule-based semantic techniques can be done today, as in other fields, by just throwing a highly parametric network on the problem with tons and tons of data. So the bottleneck for a lot of these tasks has been data throughout the years, but since the problem of warehousing high quality code has been largely solved by GitHub, GitLab, and other such sources, we now have high quality data at large amounts, and we can solve many problems by training networks. So I expect this to actually, this field to grow significantly as we move forward. So just to keep on digging into this NLP, PLP partition of the world, I'd like to talk about tasks by partitioning them to tasks that operate on code on the left and on text on the right. Really, many of the tasks that we've been looking at in PLP involve both text and code. So, for example, one interesting task that I'll talk about later is taking a piece of code, a program, and translating it to a label, predicting some label for it, which may be a label describing the program, as we saw in reverse array, or it could be a label that describes a particular entity in the program, like a name of a variable, a name of a function, name of a method, the type of a particular entity in the program. So all of these problems are kind of taking something from code space and turning it either to entities in text space, like a describing label, or back to labels that live in code space, which I cannot draw here because it becomes too complicated. Another thing that we can do is take a program and predict a description, as we did with the program earlier that we predicted replace a string in a text file, so we can have a longer description. And we can also go the other way around and take a longer textual description in natural language and either do semantic code search, looking for programs that match this description, or do actual synthesis from natural language, which is quite popular, especially in domain-specific tasks like generating queries, SQL queries from some higher level description in natural language. More tasks that stay solely in the kind of code area of the world is taking a partial program and completing it, like doing code completion or code generation of sorts. And you can also take a program and stay with the program and just do things like bug finding. So this is by no way an exhaustive list of the tasks that we are doing in PLP, but just giving you some high-level worldview to show you how we move from code to text, from text to code, or just stay with code. And NLP generally just stays on the right-hand side of this sketch diagram. So what I'd like to do now is to show you some more example of concrete tasks that are solved by current papers in the area. I'll give references to papers where appropriate, and you can look them up later. And this is just going to be some high-level overview of the tasks. Then we're going to dive deeper into one of them and see the mechanics of how it actually works. So if you just monitor time, so we'll reach that. All right. So one of the tasks, the earlier tasks that was tackled in PLP was predicting variable names. Initially, this was done by non-neural methods, I think by Raichev and Vechev back in 2015, maybe, I don't remember, in JSNice. And the task here is to take a program in which variable names have been either obfuscated on purpose or just non-descriptive names like P, C, O, and E here. And the task is to predict variable names, descriptive variable name like process, CMD, out error. And this particular prediction, I believe, is from the Code to Vec paper that I will show you later. Another task of a similar kind of nature, but slightly different technically, is to predict function names. So I give you a function here that has that performs some tasks, and the goal is to predict the name for the function. In this case, we can predict the name contains ignore case for this function. And note that this is quite challenging to do in general. I'll show you more examples of that later. Another task that is local in nature is doing type prediction, moving, for example, from JavaScript code here at the upper part of the slide to automatically to TypeScript code by predicting the type names. So you can see that owner document now has a type annotation that says that it's of type document. CSS text has type annotation saying that it's a string, etc., etc. HTML element here. And again, all of these tasks are solved by throwing a neural network on the problem and training the neural net on massive amounts of code that have probably both the vanilla form of JavaScript and the annotated and JavaScript or TypeScript with type annotations as well. All right, code captioning, I think I already mentioned, but this can be quite involved. It can predict very descriptive sentences like add a child node to a tree view in C#, etc., etc. All right, so yeah. So let's go back because there are some questions on the type prediction here. So how do you guarantee correctness of the type prediction? Well, you cannot guarantee that the corrected types are correct. You can try to use the type checker post factum and see whether what you guessed is correct or not. Again, there is no analytic type inference going on. We are just predicting types based on likely annotations or likely predictions from a neural network. There are absolutely no guarantees that these types are correct, but they turn out to be pretty good guesses of what should happen there. I think the upside is that the program does not need to be even correct or not necessarily even compile in order for the neural type inference to work. So that's kind of the upside. And the downside is obviously that what you're getting is not necessarily correct, and you will have to validate it. But I think it's pretty useful for bootstrapping kind of a project in which you have absolutely no type annotation and you want to get some guesses out there and refine them manually later. I think that's kind of a good use case. I don't know the numbers in terms of precision of these approaches, but they seem to do, as all neural networks, they seem to do very well in standard code. So if your code is following kind of mainstream patterns and mainstream practices, your types will be pretty solid. And the more you go out of mainstream and write your one-off program that the net cannot generalize to, the worse you'll be in terms of accuracy. I think there are interesting, practically speaking, there are probably interesting combinations in which you're doing some of the work by the neural net and some of the work using some local type inference to validate it, because many times you can use the local type inference at least to refine the predictions from the network, but I don't want to delve too deep into this particular task. All right, so again, the advantage of these methods, even for classical program analysis tasks, is that they can often solve problems locally, like a human would do, without having to solve the global problem. So often to do proper type inference, you need some global view of the program, but the neural net, just by looking at the local patterns, will be able to guess pretty compelling and useful types that a type inference algorithm needing like a more global view would not be able to do. So there's some of that. I cannot claim that there is a clear winner. So I cannot say that, you know, the formal way to do stuff is always better or the neural way is always better. Probably there are cases in examples in kind of both directions. So I'll hold off on a few questions and let me go through like 2-3 slides, and I'll go back to other questions, which I like. And if you vote for them, it will help me focus on the ones that are more interesting, because kind of more and more are coming in. It is pretty hard to track all of them live. All right. So code captioning I already mentioned. And of course, code completion that I mentioned as a motivating example. What I didn't show you earlier is that, again, we're not predicting a single thing. And this also goes back to the question about types. We are making predictions that are typically several predictions with different probabilities or different levels of confidence that we have to pick from. And all of these things will require, including type inference, will require additional effort by the human to be useful. All right, so in this case, you can see that what I showed you in the motivating example initially was confidence 12%, but there are other maybe plausible completions here with 4% and 135%, et cetera. And it is really not always that the first one is the best one. Yeah. So the neural network, that's an interesting question, so I'm going to answer that. The neural network does not guess only standard or built-in types. If you want to go back to the type prediction thing, it can also learn some notion of copying or out of vocabulary predictions in various ways, and it can predict types that are not kind of standard library types. But I will not show you anything like that here. I will show you maybe some examples, maybe even live. We'll see how much time we have on how these things work by using copying mechanisms to do out of vocabulary stuff. All right, so you ask about IDEs and stuff like that. So here's one example, which is Tab9, which is using neural models to do very, very expressive code completions. As you can see here, let me maybe try and stop it at some point so we can see the prediction that are being made. So you can see that these are very long expressions that are being predicted as a whole by the neural net, by the underlying neural net. And this is deeply contextual on what is available as context in the editor right now. And this is not code inspection, this is code completion. So we are predicting code, but this is very, very expressive and goes well beyond what current IDEs are doing because it is doing a very rich and expressive model. Maybe I'll show examples later. We'll see how it goes with time. All right. Let this run all the way to the end. But you'll be able to see that it does very expressive predictions, including things that you would not expect from something that is based on just formal inference. All right, another task. Again, I'm giving some overview of tasks just to get your kind of appetite going to this field. I'm not going very deep on the techniques underlying them. I'll go into that in a bit. One task that we defined recently is called edit completion, just like code completion predicts code that should come next. Edit completion are basically predicting future edits. So let's say I have a function here called getFileCharacteristics that's used to return a Boolean, but I'm now modifying it to return file characteristics. What I would like the model to predict is the edits to the body of the function, for example, in which it's used to return true, but now it will return the object new file characteristic that was created here. So the task of edit completion is one in which the user makes one edit and the model predicts downstream edits that basically are implied by the initial edit made by the user. Right? So it's kind of just like code completion predicts code, edit completion predicts edits. And of course, there are many works, as you can expect, on bug finding. This is a particularly cute one called Sequencer. And what Sequencer does, if you look at this program, you will quickly notice that there is a very simple bug here. And the bug is switching the dimensions. So the original function takes X and Y, and the user calling the function passes a parameter Y and X here. And you can detect that using neural network. And another paper detecting argument selection defects with kind of a similar idea has detected a very deep and old bug in concurrent hash map, deep in Java util concurrent library that nobody was aware of, which Doug Lee called definitely embarrassing. The bug was that you had two variables of the same type, index and size, that were defined in some way in superclass, and the subclass changed them, switched them. So this is a bug in which index was considered to be size and size was considered to be index. And the only reason that this was not discovered for many years is that there was another bug that canceled this one out, right? So, but this was quite nice. How does program synthesis relate to PLP? So PLP gives you one way to do neural synthesis. So it's like the code completion or code generation task that I mentioned earlier is sort of program synthesis without a specification. So it is program synthesis in which the specification is the context in which you are getting the completion. So for PL people, I guess this sounds strange because how do you know what you're synthesizing if you're not giving any specification? But based on context, you can actually predict quite a lot. And it turns out that users in the real world are not too keen about writing specifications in first order logic to get an array sorted, but they may be keen on selecting kind of a completion which is small enough from a drop-down list if it is kind of rich enough and based on their context. Right, so again, all these, there are many questions coming on in the stream about how do you know that this is correct, and how do you know what is the actual intent of the developer? Maybe the developer wanted to switch X and Y here, so how do you know that you are not reporting something that is actually correct? And the answer is that you don't know. Maybe Doug Lee intended to replace index and size here, so I don't know, probably not. And the whole point in PLP, or in this entire neural kind of reasoning, is that we don't know what is correct, but we know what is very likely. So if you're doing this with the point here, I don't know if you're correct or not. Maybe you're correct, but 97% of the people did not do it that way. All right, so do with that what you may. Either you're in the 3% or you're wrong. So it can alert you to things that are unlikely or uncommon, not more than that. All right, let me just look at more questions here. So yeah, are some languages easier to do predictions in general, like statically typed or dynamic typed? So there is some, depending on the model. So some models are purely textual, as we will see soon. And for these models, it doesn't really matter. Some models are more deep semantically. And for those, it may matter, like dynamically typed languages may be slightly harder. And I will maybe show why. But I think in general, the languages that are easy, it's more about verbosity than it is about types. The more verbose languages are easier just because there is much more regularity and repetition. And so as you are writing these languages as a human, you notice that you're doing a lot of boilerplate and a lot of stuff that really should not be there. And these techniques can automate a lot of it because they can also notice that it is very regular and really should not be there. So, for example, Java is a great language to do predictions for. Another, I think, distinguishing feature in terms of the ability to do high quality prediction is the quality of the training data. So some languages have more, let's call it robust training data. Java is one of them. Some languages like Python, the quality of the code that you found out there varies widely. So there are many one-off projects that are doing a certain, prototype for solving a particular data science problem, and it will be harder to get the signal, a consistent signal out of those. Right. Also, just like bug finding, you can do bug fixing. And in this case, this is from the same sequencer paper in which it found that you did next index assigned from current index, which is obviously wrong. And it can tell you that you should add one. And this is just an example, not from the paper, but from my student, Uri Alon, who wanted to demonstrate that many times in Python, you maybe are not aware of some parameters that should be passed, like the dense layer is just a linear transformation unless you add the activation here. And so again, a neural model can tell you, hey, you know what, like it is very likely, unless you're writing some strange model that is only doing linear stuff, it is very likely that you forgot to pass the parameter doing the activation here. There are some work very recent on bug localization and repair. Again, the network that is able to tell you things like, you created object name and subject name, and then you added object name to objects, and you probably copy pasted this line. And when you came to do add subject name to subject, you forgot and left object name here. And this is obviously a bug. I'm going to skip some of these, I think, at least, or is this the last one? Yeah, okay, so that's the last one, so I'm not going to skip it. We did also some work on reverse engineering, trying to predict higher level descriptions and also actually higher level code from low-level code like x86 instructions here. There's some nice paper about it that you can look at. And I'd like to spend kind of the rest of our time together giving you some idea of how this works and maybe looking at some more questions here. Let me right. See, recent. Yeah, translating programs. So the problem of translation is very interesting in PLP. And the reason that it's very interesting in general, in PLP, in the programming languages sense, is because we often have compilers or some translators that go one way and not the other, which means that unlike for natural language, where you look at the problem of translation, if you want to translate from French to German, for example, somebody has to give you corresponding text that exists in French and in German. So what you have as training data is just these texts that appear in both languages. In PLP, what you have usually is an automatic, reliable translator from one way to the other, a compiler, and you just want to do the other way around. And so you can generate as many training data, as much training data as you need, and as many examples for the cases that are confusing your model as you need. And this is actually a very interesting paradigm. We looked into that a bit, but I think this is really underexplored and many interesting things can be done there. I saw just the other day, Facebook published some work on translating between programming languages, but I think this just scratches the surface. Even when you are translating languages, I think the difficulty in translation is often in translating the libraries. So it may be very easier, maybe very easy to translate Python to Java at the language level, but it will be very hard to take whatever functionality you have in Python libraries and carry it over to corresponding Java libraries, right? And you will not be able to translate all the way down, so it will be hard. Anyway, so how does it work? I'll give you the crash course of 30 seconds most on neural networks, and we can proceed from there. So a neural net is really just a sequence of simple algebraic functions over vectored matrices. Let's look at an LLP example. Let's predict how positive is a given sentence, which is a regression problem. So you give me the sentence, a good movie. I take some vector representation of each word in continuous space, because the networks only work on vectors in continuous space. They don't know what is a word in English. And I do some, let's say, an average transformation, multiply it by some weight matrix, do some summing of the result, and then I get a score for this, how positive this sentence is, and the score is 7.3. Then I compare it in my training data to what is the actual score that is the ground truth I have from the training data, and the actual truth is 9.5. So I say, okay, there's a difference here. Let's compute the loss and propagate it backwards. You probably heard about backprop. Propagate it backwards in the network, update the weights, update the vectors, and this is usually done by gradient descent. And this is the crash course on neural networks. Of course, the reality is much more complicated, but that's kind of the intuition. And just like I took a good movie and I had the ground truth saying that the positivity of this sentence is 9.5, I will do that, say, for programs and their labels. I will have a training set that says, here's a program, here's the correct label, here's a program, here's the correct label. And I have millions of these in order to train the weights of the neural network. And once this stabilizes and the network has minimized, the training has minimized the loss, what I can do is use the trained network to assign labels, or in this case, assign a score to unseen sentences, to things that I have not seen in the training data. So a central question for us in PLP is, how do we represent the code for the network? I just told you that the network is just some composition of algebraic manipulations over vectors and matrices. A program is a discrete object, and I somehow need to take this discrete object and change it and transform it to something that the network can operate on. I need to represent it in some way to the network. Here's some transformer, but it doesn't matter. So we'll look at simpler networks in a second, network architectures. So the question, the high-level question that I'm trying to answer is, how do I take this discrete object, a program, and push it downstream to a neural network, that can operate on it and solve one of the earlier tasks that we looked at. All right, so let me stop for questions before I go into the actual sequences. Yes, I meant that paper from Facebook that you asked about, the transcoder. It's not the first one, but it is a recent one, which seems quite interesting. Compilation bugs, I don't know. Sounds very hard to me, but I don't have a lot of intuition. I think at this point, the easy compilation bugs are long gone by various formal techniques, and being able to find anomalies in the low-level representation produced by a compiler is going to be very hard using these techniques. Does it work with C++? Yes, it would work. Again, it's not features per se. I will show the representation now, and maybe it will be clear also for C, C++, and other languages as well. So again, let me break back from the question. What we're trying to do is take the discrete object, the program, and push it down a neural network. We need some representation in order to do that. One family of representations is sequence-based models, and these treat the program just as a sequence of characters, sequence of tokens, or byte pair encodings, stuff like that. So it works just as you'd imagine. You take the program, you split it, say, to tokens, which is something that is basically the first phase of any compiler, right? We're doing lexing, so that's easy for us to do for programs. Or you can break it to characters, which is even easier, and feed that to the model. And the early work on applying neural techniques to programs, a lot of the early work used these techniques, and they are quite effective. So what you're seeing here is some visualization of attention from Miltos's paper, A Convolutional Attention Network for Extreme Summarization from 2016. I will not go into the details here, but the important thing for our discussion here is that their representation was based on tokens. So you can see here that each token has different color, and the brighter red means that these are tokens that the neural model gave a lot of attention, assigned a lot of attention to. All right, so again, high level, what's good about these sequence-based models? They're very easy, simple, and once you do that, you're basically home free. You can run and train any standard neural models. You can also do non-neural models like n-grams, but also convolutional nets, long short-term memory, LSTMs, transformers, you name it. You can take any model that has been used in character level NLP and use it for character level programs, and it works out of the box. So that's great news. But the bad news is that these models are extremely data hungry. You will need a lot of data in order to kind of stabilize the weights of your network on something sensible. The models are very large. And the reason that it is hard to get them to work is that they waste a lot of capacity by implicitly relearning the program language syntax. So think about it, a model that works at character level does not know or has to relearn the fact that if you're doing, I know, open paren for parameters, at some point you should have a closed paren for the parameters, or open curly braces and closed curly brackets, right? And these things have to be relearned by the model as regularity from the training data, although they're obvious to us as PL people. We know that the language syntax, we know that the program language has a formal syntax, but the model knows nothing about that and has to relearn it from scratch. On the other end of the spectrum, so that's one family of representations is these, let's call it sequence-based or textual models that do not know anything about the semantic of the program and have to relearn both syntax and semantics from scratch based on the data. The other family on the other end of the spectrum are semantic models in which somebody, probably a PL researcher, encoded some human knowledge or language knowledge into the model, typically by doing some static program analysis or dynamic program analysis, extracting some semantic relationship between entities in the program and embedding that into the model. So I mentioned earlier the JS work by Raichev and Vechev. So in that work, what they did, they ran some program analysis. That's a non-neural model, but the same kind of principle applies to neural models as well. They did some program analysis and they established some graph representation in which edges had meaning, like whether a function may call another function or may access a certain field, or this field, this name is passed as an argument to a particular parameter, or these two pointers are aliases and stuff like that. So they did very kind of deep program analysis in order to create a more semantic representation of the world. More recent work by Alamanis and Brookschmidt. Thanks, Mark, for the slide. This is a slide from Mark Brookschmidt. Used graph neural networks, GNNs, in order to solve the task of variable misuse, find cases in which the wrong variable is used, just like we saw with flipping the height and width of a rectangle or something like that. Yes, we know GCNs. So thanks for the comment. I'm not mentioning, so as I said, this kind of high-level survey is by no means exhaustive. I cannot cover all the work. I'm covering some things that I think are representative in the space. Miltos and Mark's work here is using graph neural network. And in this work, what you do is you look at a program and you basically compute semantic edges, like this variable was last written to here, or this variable was last used here, or this variable X is computed from this variable X and this Y, and you feed this entire graph representation into a graph neural network, and you can infer all sorts of interesting things using this semantic information. So for semantic models, it is very easy to feed the data. The models are much smaller. It's easy to design more features, but they are very language specific and task specific. Like if I want to do what Mark and Miltos did for C#, if I want to port that to Python, it's going to be quite a lot of effort. It requires manual design and implementation of a semantic analysis. In fact, the code has to say compile, which is not trivial for many projects. And that's kind of tricky. So let me skip ahead for a second because I see many questions around this. So this is, if you remember just one thing from this talk, this is kind of the slide that I think is interesting to PLP. And this is like the fundamental trade-off of PLP in general. So what you see here is a graph plotting intuitively, hand-wavy, the learning effort on the y-axis and the program analysis effort on the x-axis. This is all quite hand-wavy, but there is a kind of an inherent trade-off between the amount of program analysis that you do and the amount of what your model has to learn. So on the left-hand side here, if you're taking models that learn on the surface text, what these models do, they basically have to implicitly relearn the language syntax. What this means is that they have to put a lot of effort, and effort here means amount of training data, the time used to training, the size of the model at the end, and stuff like that. So on the left-hand side, you have the surface text, and that is a really tall order for the learning. On the right-hand side, as you go further and further to the right, you're doing more and more static analysis, doing more program analysis stuff, all the way, say, to these kind of GNNs, the dependence graphs that Market Miltos had. And in this case, you're becoming very language specific and task specific. So really what you would like to do, and this came up here in this in the question, which is what you would really like to do is find some points here in the middle around ASTs.
Sorry, Eran, sorry to interrupt. Do you mind please repeating the question? This is because a lot of people don't actually have Slido open, so they're not sure they're not sure what question you're actually answering.
All right, that's great.
Thank you.
So it's good to notice that just like at the end of the talk, but thank you. So the question was whether the network, so there are a lot of questions actually, but some of them were around what is the correct representation to use here. Is it the semantic one or the textual one? Are all the networks that we're talking about language specific or not language specific? And the answer to all of these questions as a whole, so there's not a single one, is this kind of trade-off graph. And my point here really, just to repeat the high-level point, which I think is important, if you're learning just from text, you have a very hard task for the model. The good news is if you're learning just from text, this will work for any programming language, obviously, because you are relearning the language syntax and some of the semantic regularities from the textual representation of the programs. But in order to do that, you have to feed the model lots and lots of data. So the model can kind of throw away the noise and extract the signal, the regularity in the code from your example, from training data. If you're doing very deep program analysis, your learning task is easier, but you are becoming more and more language specific. And so some of the questions asked, should we use some intermediate presentation, like something that is based on an AST or something that is based on other forms of IR that we typically see in compilers? And the answer is yes, IRs are a compelling point in this trade-off graph to do the learning from. And something that is AST or a little more than AST is particularly compelling. One of the presentations that we've been using quite successfully for many tasks is based on AST paths. AST paths, just to give you the intuition, are basically building the AST of the program and then linearizing the AST or some aspect of the AST by looking at paths between nodes. In this case, for example, the path from the first occurrence of done, here is the condition, to the second occurrence of done here inside the if. And it seems a rather shallow and harsh representation of a program. But if you look at this path, it actually captures something that is interesting semantically. It captures the notion of doneness, so to speak. So it captures the fact that you have a flag that is checked in a while condition under negation, and the same flag, the same variable, is assigned somewhere inside the loop under a condition. So you can think about this offline. I don't think I have a lot of time left, so I'd like to plow through. But that's kind of the intuition. And the beautiful thing about AST paths is that they're able to generalize from programs that are otherwise textually very different. One of the problems of the textual models per se is that if the programs do the same task, perform the same tasks as here, but look textually very different, the textual models cannot generalize over that, right? If we go very deep into semantic representation, clearly that makes life easier. But even using a representation that is based on AST paths as here, if you look at these two ASTs and the set of paths that are emphasized in these ASTs, you will see that there is quite a lot of similarity between these programs, even though the text is very different. All right. So somebody asked, have you considered hooking up community knowledge bases like Stack Overflow with the PLP system? So yes, there has been a lot of work on using textual descriptions from Stack Overflow for various PLP tasks, notably for semantic code search, but also for generating captions and other tasks. It's, I think, again, it is currently underutilized, I think. One of the problems is that a lot of the code that you find on Stack Overflow does not necessarily type check, compiles, parses, or you name it. So it's kind of partial code, often with some ... in the middle. So there's a lot of smart pre-processing to be done if you want to really leverage that, but it's definitely interesting. So for the last couple of minutes, let's see, what is the questions policy? Are we stopping on the hour and that is it? And we go to Ali's talk? Because then I will just stop at this point.
You have another 5-ish minutes or so if you'd like. So if there's maybe outstanding questions in Slido that you'd like to address, or
yeah, so this is your time. If you have not asked your question yet, now is a good time to enter your question into Slido. I'll try to address them. And if there are no new questions here, let me see what are the most popular ones coming in. Hang on. Yeah, so I think let me take 1 more minute to talk about attention, and then I will answer some of the questions here. Oh, that's a hard question, Horst. Thank you. What do you think is the biggest fundamental limitation of current approaches? So let me think about that in a background thread while I show you some examples that are showing attention. So if we look back to the image that I had in the beginning of the talk, the prediction of the person is riding a surfboard in the ocean. If you look at what the network does, it uses a mechanism called attention to kind of predict each word in the caption separately. So you can see the person is riding a surfboard. So you can see that the word person, for example, the highlighted things in white are basically where the network focused attention. So you can see the network focused attention around the person. If you look at the word ocean, you see that the network focused attention mostly around the waves here and not the person itself. So the same kind of intuitive notion of attention also exists in many of the network I showed you. For many of the tasks, it is a fundamental piece. And one thing I wanted to show you is kind of the attention mechanism in Code2Vec. The reason I like Code2Vec as an example is that it is a very simple architecture, very simple neural architecture. You can use that as your kind of hello world example into the area of PLP. All the code is open source here on GitHub, and I think many people have used it for various tasks because it is very simple. It is simple to modify, and I think simple to understand. So I will not explain it because I will not have time. I just want to mention that one of the key components in Code2Vec is the attention. Let me skip a lot of the things here. Yeah, I'm going to skip this, although it's nice. And I'm going to take you to the Code2Vec website here, just to show an example. Let's take a simple one like this one. You can see the program here, and I can ask Code2Vec to predict the label. And Code2Vec says that the label is contains. And what you see on the right-hand side here is the AST and the paths in the AST, and the colors don't matter. What matters is the width of the lines. And you can see that the widest line here where the network focused attention is on the path that goes from elements through the for each with the if statement and returns true, which basically, if you want to translate it to a human, it means this code has a path that does iteration over an array, over a collection called elements, and under some condition returns true, together with the other paths here, like a default path that returns false if you don't find it, and the fact that the method returns Boolean, I can predict with high probability that what you're doing here is contains. So I just want to show this as a kind of a short example, and I'll stop now and look at the questions. I did not forget your hard question of what is the kind of biggest fundamental limitation of the current approaches. What is the task that current approaches cannot tackle successfully? So for many, so it's an excellent question. I think Mark Brookschmidt has observed this I think maybe even several years ago, that the bottleneck for many of these tasks is the absence of data. So if you're trying to do something like bug finding, you would need a model, you need training data that says this is a bug and this is a bug of this sort, this is a bug of that sort, and you're unlikely to find such high quality data to train on. Similarly for tasks of edits, unless you have some instrumented editor in which you have recorded edit sessions of many users, like you can do, for example, if you work for Google, you don't have the high quality data that is required for these tasks. So I think the inherent bottleneck for many PLP tasks is actually the absence of high quality data. If you're looking for interesting research problems in this area, I think one underutilized and underexplored place to look is actually at program executions. This is a rich source of training data, and not a lot has been done there. So I think that's an interesting place to look. Yes, the question is, what might be ways to inject semantic understanding into these neural models? So I think we've seen some of that, like in the GNN models that I talked about, in which you actually inject these as edges into the neural model, into a graph neural model. So I'll try to go back there if that works. So I think these are the most advanced attempts to inject sort of semantic knowledge. It is still quite low level, like last write, last use is very low level semantic information. Maybe there are better ways to inject higher level information. I'm not sure, but bear in mind that as you inject more semantic information, your models become more language specific, obviously, and more task specific. That is something to keep in mind. So I think I'll respect time, at least in some approximation, and I'll jump to the summary slide here, which is maybe this. Yeah. All right, so there's a bunch of stuff that you can look at later. Most of it is the org stuff is open source, and you can play with it. Tab 9 you can download and play with, and it can work for any language. Code to Vec, Code to Seek, and any code prediction, code engine, you can play with the website, with demonstration website, and see a lot of other cool PLP tasks that are mentioned in these papers. So I think I'll stop at this point, and I'll let Ali continue. Yeah. So
Great.
Thanks.
Thanks so much, Eran. It's virtual setting. It's hard to have a round of applause from everybody, but we do have about 340 people watching the live stream at the moment. I'm sure everyone is applauding in front of their screen at home. So
Right.
Thank you very much. It was a really wonderful talk and a great overview, and we can tell from the number of questions generated, I think a lot of interest in it.
Yeah, so thank you, and thank you guys. If you have further questions, feel free to just shoot me an email or DM me on Twitter. I'm happy to engage in discussions around this area. So at this point, I'll go offline and let Ali talk. All right. So thanks a lot, guys.
Great. Thank you. Okay, so with that, we're going to switch over to our second talk of the session, a mentoring talk by Ali Donaldson. So Ali, please feel free to go ahead and start sharing your screen. We'll see how it sets up. So Ali is, a brief introduction, Ali is our illustrious leader. He is the General Chair of PLDI 2020, and he's really done an amazing and monumental task of moving PLDI online. So massive thanks to Ali. Thanks so much for that. It's really been amazing. And session one so far, first day, going well so far. So Ali, his day job when he's not running PLDI is faculty at Imperial College London, where his research focuses on building efficient and reliable applications on multi-core systems. He's also a software engineer at Google, and this is as a result of founding a company based on his research that Google acquired. So today I'm very happy to welcome him to PLMW for a mentoring talk on managing the burden of novelty in research. So Ali, over to you. Thanks.
Thank you very much, Stephen. Can you hear me and see my slides?
Yes, we can hear you and we can see your slides. Thanks.
Good. All right. Well, thank you for the very nice introduction. And thanks to you, Millen, Nadia, and Adrian for doing a great job of organizing virtual PLMW. What I'm going to do in this mentoring talk is to try to reassure you that if you're having trouble thinking of novel research ideas, then you might not need to stress out too much. There might be some strategies you can employ to nevertheless do really fun research and get your work published and get out there in the world, and also further your career, whether you want to be an academic researcher or an industrial researcher, or whether you just want to get to the end of your PhD and be done with this whole academic thing. I've called it hacks to compensate for lack of novelty, because the idea here is I'm not saying I'm going to give you a cookbook of idealistic things you should do in your career. I'm more saying if you're having difficulty, here are some things you might try that might help you out. I would love to get questions throughout the talk. I'm probably not as good as Eran is at monitoring Slido simultaneously with looking at my slides and speaking. So Stephen, I'd really appreciate it if you could perhaps just interrupt me if questions come through. I'll try and keep an eye at the same time, but I would rather take questions during rather than at the end, and I'm happy to be interrupted at any
Thanks, I'll try to do that.
Great. Okay, and I've also got a poll on Slido, which it'd be great if you could make it live, Stephen, if it's not live already. Yeah, so there is a live poll on Slido. You probably have to go to the polls tab to see it. And the meaning of this poll will become clear in a few moments, but there are various sections to this talk, and it's a kind of choose your own adventure style talk, and you can get to pick what I will talk about. If there's time, I'll talk about all of the different bits, but otherwise I'll prioritize them according to popularity, and that'll become clear in a couple of minutes once I keep going. All right, so novelty. Really important in research, in academia, in research and industry. We're often talking about the novel contribution of this paper is the following. Right? We're talking about what we bring to the field in comparison with prior work. And as researchers, novelty thus has really high importance to us. And the importance is both fundamental and pragmatic. So fundamentally, doing something novel is really satisfying. It's really, really great when you do have that feeling, sometimes a rare feeling, I find, but that feeling where you think, I've come up with something a bit different, a bit new here, it works really well. It's an amazing feeling. And I think that novelty is partly what draws us to be researchers. And of course, novelty is really important to advance the field in the long term. If we don't have novel science, then we're not going to bring science forward. Also, there's a pragmatic side to this, and I want to be very kind of pragmatic in this talk and acknowledge the fact that we all need to earn money to eat. We all need to finish our qualification, our PhD, for many of you. And we all are, to some extent, ambitious and maybe thinking about getting a job at a good place or getting promoted. So actually, novelty can be pretty important for getting papers published, and it can be important for getting research proposals funded and for various other things in our field. And actually, I would say, because I'm going to be almost a bit negative about novelty in this talk, and talk about things you can do if novelty isn't flowing for you, but I want to acknowledge that actually one of the best things about being a researcher is that you're paid to be novel. You're paid to think up new stuff every day, and that's a real privilege, and I don't want to forget that in the rest of the talk. However, I personally find that the seeming requirement of novelty is one of the most difficult things about being a researcher. I often find myself in this downward spiral of, first of all, having an idea and thinking, oh, you know, that might work really well, and being excited. And then thinking, well, you know, is it new? Would it be perceived as new enough if I'm thinking, you know, to finish my PhD, I need another paper to graduate? Or if I want to try to get a job at some institution, I probably need to get a paper at Popple. Will it be perceived as new enough by that community? Okay, I think it will, and I think it's new, but then you can wonder, have I read enough literature? There are hundreds of papers out there. Some of them are impenetrable. I've read loads of them. I want to get on with this idea. I don't want to just keep reading more and more stuff. But what if I find out that actually it's not as new as I thought? What if you find a paper and you think, this work I'm doing is certainly different from that paper, but I can't really understand that paper because it's so badly written. It's an incredibly impenetrable paper, and I can't make head nor tail of it. I can tell it's related. I don't think it's got my idea in it, but will other people who maybe understand that paper better than me say, oh, actually, this was all done by so-and-so in 1986. And I think there's a danger that due to these concerns, instead of just following our interest, we can end up looking for novelty, thinking, okay, you know, I'm not going to necessarily do the thing that I want to do or that I think is best to do. I'm going to try and find something that will be novel so I can have that wow factor that lets me get top paper at some conference to further my career. And I think that is not a good mindset to end up being in. It's a very forgivable mindset to end up having, but it's not the kind of mindset we would like to have as scientists and academic researchers. So if we were in a room together, I would right now ask you all to tell me if you've ever struggled with novelty, whether it's novelty in your own work, being scooped, not being able to think up new ideas, or whether it's novelty in people whose work you're involved in, maybe if you've had the opportunity to supervise undergrad students, if you're a PhD student. As it's going to be hard for people to shout out here, I wonder two things. Maybe the organizing committee could share briefly some stories of their own for a minute or two here. And if you do have examples you'd like to share on Slido, then we could read them out. Don't feel any pressure to do so, but if there are examples you have, it would be great to hear them. So Stephen, Adrian, Millen, Nadia, do you have anything you'd like to shout out here?
You want to just jump in with voice here, Ali?
Yeah, please, yeah.
I had a really a painful experience with novelty when I took some research we were doing and I tried to like frameworkify it. So instead of building like individual point solutions, the idea was, without getting too specific, was to build sort of one great framework that would allow people to build all kinds of solutions on top of our like compiler infrastructure we were going to build. And this read to absolutely no one as novel, because essentially we were able to like reproduce several papers that had existed before, but in a way that we thought was like kind of nicer. I don't know. It was I still think that work was really cool, but nobody else did.
Industry that work potentially has a huge amount of impact, right? I mean, if you build such a framework, it may be usable by a whole load of researchers and maybe a vehicle on which they can make all kinds of novel contributions. And yet it can be hard to kind of convince people of its value without doing a whole lot of that work yourself, not only presenting the framework, but showing multiple instantiations of it to demonstrate that it does the job. And that can end up being a huge amount of work.
Exactly, yeah. Right.
Anyone else got anything to share?
Sure, I can share mine. Actually, the very first time I submitted a paper to PLDI, it was during my PhD, and my work was on verification of object-oriented libraries. And sort of the point of this work was to develop this very practical technique that applies to like a real library. And we did a lot of work to verify this big library. And so we submitted to PLDI, and the reviews we get back is, this is not really a research paper, it's just an exercise in verification.
For me personally, some of the issues of novelty are following interests and coming up with, I guess, very specific questions. So maybe the idea of incremental advancement. It's not this, answering that question is not going to start a new field, but it's actually a really deeply technical and intriguing one.
All right, well, thanks to all of you for sharing those. And in this talk, I'm going to share a bunch of examples from my own career. So what I'm going to do in the rest of the talk is give you a cookbook of suggestions of things that you might find useful to help you when novelty is thin. And first of all, the cookbook of suggestions is not idealistic. As I said earlier, I'm not giving you some examples of like how I think you should behave at all times as a researcher. They're rather tactics to help you cope with the scenarios that perhaps you wish you weren't in. Like maybe you're struggling to get a piece of work published, and maybe now you don't like the work anymore, but nevertheless you've worked on it for ages and ages, and you do really want to have it see the light of day and get it published. So yeah, I'm talking about the tactics to cope with scenarios that are maybe not themselves ideal. Nevertheless, I hope you'll agree that everything I'm going to suggest to you here is ethical, because they're all things that I've employed in my career, or nearly all of them, as I'll illustrate during the talk. I do fairly practical work in programming languages, and most of the examples relate to practical work, like running experiments and building tools. I hope that there are a bunch of theory analogs, but I don't really have them to give you in the talk. And actually, most of the things I'm going to say probably apply to computer science more generally than programming languages, and many of them just apply to academia in general rather than even computer science. So the talk is a choose your own adventure style talk where I've got 5 different sections I could give you examples of novelty hacks for, things that I've found useful in my career. So there's a question, what does scooped mean? And the answer given by a moderator is correct. Being scooped is where you've been doing a piece of work, and actually just before you manage to submit it for publication, someone gets there first, someone else publishes a similar piece of work, usually by coincidence, because you're working on an interesting problem and other people also find it interesting and they solve it or partially solve it or do something uncomfortably related to what you've done and get it published before you. So that's the meaning of the word scooped. Yeah, so we've got how to cope if you work in a crowded field, how to cope if someone gets there first, if you get scooped, how to help a student who may be floundering. I appreciate that few of you watching this probably supervise students, but perhaps you may be a student being supervised. So the advice might be relevant to you now as someone being supervised, or maybe later in your career if you become an academic. Advancing on flawed prior work. So it's hard for you to be novel because there's existing work, but it's really bad, or you think it's really bad. Or work that doesn't have a wow factor. So there's nothing wrong with the work, but it doesn't contain necessarily a big new idea. So I'm going to have a look at the poll, and I don't know, Stephen, whether I can see like results as they come in. At the moment, it doesn't look like it.
Yes, once you've answered the questions, you'll see the poll and those results being updated live. So currently the leader is no wow factor with 67% of respondents
Cool.
marking that.
Okay, so I will go for that one first then. No wow factor. There's nothing wrong with this piece of work, but it doesn't contain a big new idea. So I'm going to give you a suggestion that might sound offensive, but it's a serious one, which is try a journal. Now, in computer science, and in programming languages in particular, we typically publish our best work at conferences. Now, these days, some of these conferences have applied a hacker of their own, and technically they're now a journal. So, for example, POPL, ICFP, and UPSLA, which are three of the top conferences in programming languages, publish their proceedings in the Proceedings of the ACM Programming Languages Journal. But really, they're still conferences. They have a single annual deadline. And PLDI is the one SIGPlan conference that has not even subscribed to the PAC-MPL model. And then in addition, we have a whole lot of journals in our field that I think most people would agree are less high impact than conferences. And I think that sometimes a journal could be a really great thing to consider. If you've done a piece of work that you could write up into a paper, and if it makes a sensible increment, or it makes several related contributions, but for which it's a little bit hard to write the introduction where you say our key idea is blah, or our main contribution is this one thing. If actually what you've done is worth publishing work, but not necessarily work that blows people away, it might fare better with journal reviewers in terms of its chances of being accepted than at a top conference. And remember here in this talk, I'm being kind of tactical. I'm talking about how to get things past reviewers. I don't mean that in an unethical sense of how to do work that's substandard and get it past reviewers because they don't notice. I'm saying if you've done good work, but maybe the work lacks some wow factor, how might you nevertheless get reviewers to appreciate it for what it is, agree with you that it's worthy of publication, and get it published so that it's there for all time? So a great thing about a journal is that there's time for revisions. Some of our conferences, or most of our conferences, have a rebuttal period where you receive reviews and you get a very short period of time to rebut them. But let's face it, the rebuttal period rarely helps. It's very rare to get a paper where you've not got strong support and write a rebuttal and manage to turn the reviewers around. I often find that I spend a long time writing a rebuttal, and then when I get my paper rejected, the reviews are verbatim what they were before the rebuttal. Program chairs have become better at getting reviewers to update their reviews following a rebuttal, but I was program chair of eCoop 2019 last year, and I had a really hard time getting reviewers to, so I mean, some folks were fantastic, but I had a hard time getting reviewers to update their reviews at all following the rebuttal period. And I found that many reviewers would just, wouldn't really consider changing their opinion of the work based on a rebuttal. I think with the journal, the situation is different because you can ask for a resubmission. You can ask for the work to be resubmitted with corrections made, either minor corrections or major corrections, and you can submit a substantially improved paper that gets re-reviewed. And I think, being re-reviewed when you actually show the review you've made a whole lot of changes, I think that makes it massively more likely they might change their mind, rather than you not changing the paper, but just arguing why actually they're wrong, or arguing why you could make some tweaks in the final version to make the paper better for publication, which is what you have to do at a conference. Another good thing about journals is you're not being compared directly against a stack of other papers. When we review for conferences, we're not supposed to make comparisons between papers. And I certainly don't explicitly do that. But if I'm reviewing a pile of papers for PLDI or for POPL or for one of these conferences, it's very difficult not to start even unconsciously ranking them against each other and thinking, you know, is this paper as novel as that paper? Even if you're not doing it explicitly, you'll be doing it unconsciously. Whereas when you review for a journal, you just typically review a paper. Like I do a few journal reviews per year, I read a paper and form an opinion on its own. And I think sometimes that can lead to being more sympathetic to a sensible paper that has a good piece of work in it or several related contributions, but maybe doesn't have a big wow idea. Okay, I'll give you an example of my own in a minute, but I wonder, has anyone got any questions on that first?
So there was a question about the wow factor. How to cope when you think it's a good idea, but your advisor or community isn't convinced by your motivation?
That's a good question. So there are a couple of things there. So first of all, you may be in the unlucky situation of having an advisor who is not willing to let you submit your work to a top venue because they don't think it's got the wow factor, and they don't want people to review the work, and I don't know, maybe think that they submit work that doesn't have that wow factor. I would compel you to argue with your advisor in that case. If you believe in your work and if you think your work is good, then you should submit it to good places, and you should ask your advisor if they would be okay with you submitting it without their name on it if they disagree. As advisors, our job is to advise, that's in the name. And I've certainly had cases where my students have submitted work that I've not been super comfortable with. I felt like, you know, it's not really up to my standards, but nevertheless, the students worked hard on it. It's their work. My name's on it because I did contribute significantly to it. But just because it's maybe not the work I would have dreamed of doesn't mean the student should not be able to submit it. So first of all, in terms of whether you should submit your work, if you believe in it, you should really argue with your advisor and get them to give you very concrete reasons for why. If they think that the work is wrong, then fine, if they can convince you it's wrong. If they think the work is flawed, and I mean seriously flawed, because let's face it, all work is flawed. If they think the work is flawed because you've done the statistics wrong, or flawed because there's an incorrect proof, then that's a good reason not to submit and to do more work. But if they just say, you know, I don't think we should submit because I think that people won't be impressed enough, then I think you should have a good conversation with them and think, well, can they advise you on a better place to submit, or can they advise you, you know, when a bit later to submit? But if they're just saying, let's not submit this, then you should argue with them.
And there's a related thank you. There's a related question, which is phrased as a comment. I'll rephrase as a question. Novelty depends on culture as well. So this wow factor that we're talking about, given that it might be different in different research subcommunities, how do we ourselves recognize it, or so that we can address it in the ways that you're suggesting?
That's a great question. I think I'll come back to that in a couple of slides because I've got something about different communities coming up. And indeed, I guess the follow-on for the previous question I was going to say is, if you have submitted work and you've received reviews and knock you down, that's a bit different from arguing with your advisor, because you can't argue with what your peers actually think of your work when it's several of them. And then you probably do need to go and think about how to resell the work if you truly believe in it, which could be rephrasing it for your community, or it could be finding a different community who might appreciate it more, or deciding you want to publish it in some, you know, second-tier journal if you are convinced eventually that this work is fine but isn't amazing, and maybe maybe that's true and you accept it and you get it published somewhere decent and move on. Here's an example of a paper that I had rejected from the OOPSLA 2014 conference, and it was the kind of weak reject, weak accept type reviews where no one was strongly against the work, but they all criticized it for not having, I think I can quote almost verbatim from one reviewer, the key new idea that one expects from an OOPSLA paper. And I don't think, you know, I mean, I'm not bitter about this rejection. I think it was, as most rejections are in the fullness of time, probably a good thing, because the work that gets published eventually tends to be better. But I remember reading that thinking, I don't think that the call for paper says that every paper has to have a big new idea. It just has to make a contribution overall. Anyway, you know, we worked for a long time on this, and we did a lot more work, but we didn't get a big new idea. And we had this paper published in IEEE Transactions on Software Engineering, which is a very good software engineering journal. Having a paper in that journal, I'll be honest, doesn't excite me as much as having a paper at OOPSLA. But nevertheless, we got the work published. It's seeing the light of day. Hopefully people can benefit from it. Another one was a paper about termination analysis for GPU programs that I did with my postdoc Jeroen, who was also involved in this other paper I mentioned, and in many more papers that we did get published at top places. This was something that Jeroen wanted to try, and he wrote a nice paper on it I contributed a bit to the paper, and we thought, yeah, let's try and get this published. We tried, I think, formal methods in system design, and they rejected it, saying, there's nothing wrong with this paper, but it's fairly straightforward and fairly obvious. So we rewrote it a bit and we submitted it to another journal, Science of Computer Programming, which is also a perfectly good journal, and it was published. And now it's out there. It's perfectly good work for the community to use if they wish. But I agree with the reviewers that the results of this work were not that surprising. Nevertheless, we did it. It was a nice paper. I think it's worth being out there. Another thing you can consider is doing a case study or an experience report. So here's a paper on floating point symbolic execution, which I'll talk again in a different section of the talk, that actually we'd had a broader ambition for this work. We'd been looking at doing a whole load of work on how to do floating point symbolic execution in novel ways, but it ended up taking a lot longer than we had anticipated to even get this work off the ground, and just integrating floating point support in a nice way in CLI ended up being a pretty difficult job. So we turned this into an experience report for the ASE conference, Automation in Software Engineering, or Automated Software Engineering, I don't quite recall the acronym, and turned into a really nice report that was well received, and quite crucially also allowed my PhD student Dan to graduate from his PhD, which is really important thing to consider when you're advising students. And it, in fact, won Best Experience paper at ASE, so that was a nice thing, even though it didn't turn into necessarily the research paper we'd initially dreamed of. The experience report worked out really well and won an award at this conference. Okay, another thing you can do if you have got a paper that doesn't have a lot of wow factor is just relentlessly show that it works really well, to the point where no one can really argue with it because you've provided so much empirical evidence of its value. So a story I have here is that I read a couple of really good and very novel papers about C compiler testing a few years ago by other people. There's a paper from the University of Utah about CSmith, which is a generator of random C programs that you can use to test compilers. The programs have been cleverly generated so that they're free from undefined behavior. And that means that if you compile them with two different compilers that agree on implementation defined behavior, and you run the resulting binaries, they should give the same outcome. You don't need to know what the outcome is. If they're different, you know that there's a bug in one of the compilers. That's called differential testing. And there's another paper from UC Davis called equivalence modular inputs testing, or testing compilers via equivalence modular inputs. And the idea here is you take a program and you identify some statements in the program that don't get reached by a particular input, and you delete those statements at random, and you end up with a family of programs obtained in this manner. And when you take one compiler and compile all those programs and run them on that input, they should all give the same result because the statements you messed with weren't reachable. And that both of these approaches found loads of compiler bugs. So I really enjoyed reading these papers. I thought they were such clever ideas. And I had a master's student called Christopher Libri try these ideas out for OpenCL, which is a programming model that's used a lot for programming graphics processing units, GPUs, which is something kind of architecture I'm interested in. And this was really a reproduction study with some novel twists. So what we tried to do is take the ideas from the CSmith paper and the EMI paper, and we tried to reproduce them, but not reproduce them for C compilers, reproduce them for a different domain. So see how well they transfer to this programming model called OpenCL. And in order to do that, we needed to inject some novelty. There were some problems that were specific to OpenCL that we needed to solve. And we submitted it to PLDI 2015, and the reviews came back saying that, you know, there's not really huge ideas here, but it's a well-executed paper with very strong experimental results. And if you look here, we tried 21 different implementations of OpenCL, by which I don't mean completely different implementations. We tried like various different driver versions from NVIDIA that had different implementations of OpenCL in it. We found a whole load of bugs on a whole load of these architectures, and we gave examples of the bugs and drilled into the details of them. And I think in the end, you know, we had so much kind of empirical evidence to show our approach had worked, and it was in a different application domain, and there were some novel twists. These things combined outweighed the lack of wow factor, and the reviewers accepted our paper. And then we actually got some feedback from industry that it would be more interesting for them to have something like this for OpenGL, the real graphics programming model, not OpenCL, which is more for doing computation on GPUs. And we did a piece of work that was accepted at the 2017 conference using metamorphic testing, generalizing the work on EMI, equivalence modular inputs testing. And this had some novel twists, but still not a big new idea. But we actually found even more bugs with this work. We were able to find bugs on iOS and Android and Windows and Linux drivers and in WebGL, and some security bugs too. And again, that I think was what allowed the paper to be published at a really good venue. And this ended up being what led to me now working jointly between Imperial College and Google, because it led to the foundation of a spin-out company that Google ultimately acquired. So in some ways, for me, doing this spin-out company was quite a good adventure, and it's been really cool. Then joining Google, in a way, not going after novelty worked out really well for me here, because it led to something very practical. In order to get lots of experimental results for a lot of platforms, we had to make essentially a product. We had to make something that could work on all these different devices. We had to be able to manage the data we got back from all those devices. So we had to have a kind of user interface to allow us to actually query the data. Before we knew it, we built a prototype of a product we could try and go about selling, which led to the foundation of our company. And that's definitely something we wouldn't have done if we thought, you know, this looks fun, but not really novel enough. Let's shy away from it and try and think of a novel idea of our own. Okay, and to go back to the second question that was asked, another thing you can do is to consider a different community who might be more appreciative of your work. I have an example here from a paper with a couple of collaborators of mine on analysis of concurrency bugs in device drivers, which was, in my opinion, a really nice example of formal verification applied to a systems problem. And we had a nice time doing this work. And when we came to think where we would publish it, my assessment here was that the verification contribution would be regarded by a conference like CAV, the Computer Aided Verification Conference, as a nice use of known techniques with no particular advance in verification. And I figured that by the systems community like OSDI or SOSP or Eurosys, probably the contribution would be a bit preliminary. We maybe hadn't gone as far as we wanted in terms of being able to apply this to lots and lots of different drivers and really drill into the systems details in the way that those communities would require. And my student Pantazis actually wanted to move on to something else. He didn't want to work on this topic for too much longer, and for good reasons. He had an exciting opportunity to work on something else that he wanted to move to. So we actually decided to pitch this to the software engineering community, and it was appreciated as a nice combination of formal verification applied to a systems problem, which sort of ironically, but maybe understandably, is something that maybe neither a top verification conference nor a top systems conference is that interested in. But a software engineering conference, which is a bit of a kind of meet in the middle, really did appreciate the work, and I think it turned into a nice publication. Okay, and I guess the final strategy is just shelve it somewhere reasonable. So if you've done some work, it's turned out not to be super exciting. It's also turned out not to be scientifically flawed. There's no one around to take it further, but it's worth communicating it to the world nevertheless. I would say there's no harm in publishing it somewhere decent, if a bit lower ranked. I think it's better to do that than to deprive the world of this knowledge. And I think that hopefully no one would disagree with that. I know some people are a bit snobbish about publishing work. They don't want to publish at a workshop with proceedings or at a conference they don't regard as a top venue. I think that's an unhealthy attitude. I think it's good to be ambitious. I think you should try and send your work to the most high profile places where it will get a lot of publicity. But I think if you've done some work and you don't think it will, or you've tried and it hasn't been accepted to those high profile places, I think the idea of just abandoning it and not telling anyone about it would be a real shame. Okay, so that was the end of that section of the presentation. I'd be very happy to answer any questions if they've come up in Slido, but otherwise, based on the poll results, I would go to the next popular section.
One question that just came in related. If struggling with novelty is such a common experience among PL researchers, could it be that our standard for novelty as a community is too high?
Yeah, I think that's a good question. And I think the answer is yes. I think that in our community, we do place too much importance on novelty. As a result, we do not end up with, in the practical world, really reliable tools that people use because they work and that we can build on. We don't end up with a wealth of great benchmarks that people have curated that other folks can use. In the theory world, we end up with hundreds of separation logics, and I'm saying that because I think Matthew Parkinson has a paper called The Next 700 Separation Logics. We end up with loads of separation logics. I don't know anything about separation logic, so I don't want to speak ill of any one of those logics, but I don't think we've got many papers where people have taken a separation logic and actually tried to apply it to a whole load of different problems and looked at the pros and cons of that logic in comparison to another logic, because I think it's difficult to get that kind of work published because of lack of novelty. So yeah, I do think it's a problem, and I think, you know, more senior folks can contribute by being really enthusiastic when people do submit papers that do actually try to corroborate existing work or provide experience reports or provide infrastructure like of the nature Adrian mentioned before, which sounds like it could be incredibly valuable, even if there's not anything particularly novel about the specific infrastructure.
So several follow-up questions, I guess. So if is it the novelty isn't the right metric to be optimizing for? Question. And Anna asks, how might you contrast novelty and impact as values to work for in your research?
Yeah, I don't really have very good answers to either of those. I don't think we should optimize for anything in our research. Now I know that in practice we do, but I think we should try not to. I think we should try and do. I think we should try and do what we think is the most interesting thing, what we think is the right thing. I think we should try and convince our peers that it's a useful thing to have done, and if they're reasonable and if we do a good job, hopefully we should succeed. So I mean, in practice, one sometimes optimizes for novelty because the field isn't as open-minded as that, and one wants to get one's work published. So goes that way, you know, almost by being forced to. Yeah. And could you repeat the second question? Sorry.
That was discussing the relative novelty versus impact.
Novelty versus impact. Yeah, I have a slide on that at the end, so I'll
okay.
Hopefully address.
And I guess one follow-up question, because it is related at the moment before we move on to the next topic. Do you see more, quote, scientific and practical benefit, end quote, from novel or less novel published papers?
I think probably from a novel paper followed by a number of less novel papers. That's the ideal thing. So having a well-executed paper that introduces some new idea, hopefully with substantial evidence related to that idea. Sometimes not, though. Sometimes there are new idea papers that present a possible wacky idea that people might want to consider looking at, and then papers later that actually really flesh that idea out. But I think it's dangerous if we're not able to publish those follow-up papers at venues that people rate because they don't have a brand new idea of their own. And I think it's really unhealthy if every paper ends up having its own big idea, because then you don't really ever corroborate the other ideas. Yeah, that can be
right. Very good point.
What would you say I should go for next then, based on the poll?
So on the poll, the second most popular one is coping with a crowded field. 55% of the 122 respondees.
Coping with a crowded field, let's do it. So one thing you could do in a crowded field is do a survey of the field. I had this problem when I did my PhD. I worked on a topic called symmetry reduction in the field of model checking. Model checking is a particular kind of formal verification technique, and symmetry reduction is a way of making model checking scale a bit better by, when you're exploring the state space of a model, trying to explore states that are equivalent to one another up to rearrangement of something, like rearrangement of process IDs or rearrangement of certain data values. I actually got into this kind of by accident. When I was an undergraduate, I loved group theory. I did mathematics and computer science as a joint degree. And I really loved group theory, but I also really loved computer science and programming. And I kind of just wanted something that would let me do loads of programming and learn a whole lot of group theory. So I ended up doing a PhD on symmetry reduction in model checking, because there were these papers that talked about groups and subgroups and normal subgroups, and that really appealed to me. And by the way, I think it's good to make sort of silly decisions like that in your career and do things just because they sound interesting. I think I like not being too clinical and weighing up all the pros and cons and then deciding what to work on. I think being a bit impulsive and thinking, I really like this idea and I like that idea, let's see what happens when we work on them together. I think in general, that can be a really good way to be. But it did turn out that there were dozens of works already on the topic of symmetry reduction in model checking. And it was difficult for us to know, my advisor and I, where we could make some sensible contribution. My advisor, she suggested that we first write a survey article about those many papers that already existed, because those papers all use different notation and they all had different contributions, and having a good article that would actually organize the field and, you know, provide a way for others to navigate it might be a valuable contribution, and then would put us in a really strong position to decide whether we wanted to do follow-up work, and if so, what the work would be. So we have this paper published in the ACM Computing Surveys Journal. My advisor is the first author. She really spearheaded this survey. And yeah, symmetry in temporal logic model checking. And actually, this is my second most highly cited paper, and it's probably had a lot more impact by virtue of other people being able to read it and benefit from it than the novel work I went on to do in my PhD. So I'm really glad we did write this survey. I think this was a bigger gift to the community than the specific new papers I did for my PhD work. So let me say something about the pros and cons of doing a survey. First of all, it's got a lot of work to do a survey well. Really, if you want to do a good job, it takes a lot of time. And it's a big service to the community if you do it well. But of course, if you write a bad survey that does nevertheless get accepted for publication, that's a disservice to the community. So I would say, encourage you to consider doing a survey if you're working in a crowded field that doesn't have a survey, but be sure to do a good job of it. A survey can end up being really highly cited. And remember, again, in this presentation, I'm talking tactically. I love it when people cite my work, but I acknowledge that people are obsessed sometimes with citations, and I don't think we should be obsessed with citations. But nevertheless, being cited can be important in one's career. So for what it's worth, a survey often it does end up being highly cited because it can be easier for people to cite the well-known survey on the topic than to go and cite all of the right articles. So often people cite like some of the seminal works in symmetry reduction, and they cite my survey, and they don't cite any of the papers that I wrote on symmetry reduction after doing the survey. In the UK, we have this thing called the Research Excellence Framework, where every 6 years, academics in the UK get evaluated on their research papers, and surveys explicitly can't be submitted for that evaluation. That's potentially something you might want to consider if you're worried you don't have enough papers for some annoying evaluation that you have to go through. Then a survey might not be like the best thing for you to suddenly start working on, or the best thing for your department. It's more something you should do out of true scholarship and a true piece of service to the community you work in. I think a great thing about doing a survey is that it forces you to read loads of papers in the field, and that can then generate really good novel research ideas. So you may use it as a tool for coping with lack of novelty, but it may end up leading to lots of novelty. And one thing to say is that you don't need to be an expert in the area to do a survey. Ideally, you should already be a bit in the area. It should be something where you started doing some reading. But doing the survey will make you an expert. And actually, often the experts in an area don't go and write surveys because they're so deeply ingrained in what they're doing, or maybe they're too busy or think they're too busy to do it. If you're a relative newcomer to the area and you can read the literature well, you may be in a much better position to give a good summary of how the field looks, maybe in a better position than some of the people who are already so deep in the field that they don't quite see the wood from the trees.
A question just came in that I feel you just answered, but in a crowded area, would a survey not fit better at the end of your PhD when you actually know yourself around the field instead of the beginning? I think this speaks exactly to that.
I think that's a valid point. The survey might fit better at the end of your PhD. In my PhD, I've presented it here as if I did the survey and then when the survey was done, started working on other techniques. That's not really true. I mean, I was reading these papers and working with my advisor on how we should categorize them. At the same time, getting these new ideas and starting to work on my own contributions with more confidence that I was breaking new ground because I'd read a bunch of papers that I started to feel confident that I wasn't just doing things that other people had already done. But indeed, I think doing a survey at the end of your PhD might be a really good thing to do, regardless of whether you've struggled with novelty during your PhD. And I think doing a survey is a good thing to do at any point in your career, actually. I would love to do another one sometime. Okay, another thing that can be good to do in a crowded field is an empirical study, and I would actually probably emphasize this more than a survey. A crowded field has many papers, all of which are the best, right? Every paper you read is the best. It beats other papers because it's new and it's the best. Now, obviously, I'm exaggerating here, and I don't want to make it sound like my colleagues in programming languages are all dishonest. What I mean is that it's quite common when writing a paper to end up with positive claims you want to make. You might want to say, you know, our technique in this way is superior to a bunch of other techniques. And there's another technique that says our technique in this way is superior to all these other techniques. And oftentimes those claims are all true, or they may mainly be true. Maybe they're not all true, but they may not have been very thoroughly evaluated against each other. And actually doing an empirical study where you get a bunch of different tools in an area and you get a bunch of different benchmarks and you ask several research questions and you evaluate the tools against the benchmarks, and you don't have to worry about which tool is yours because none of them are yours. And you don't need to worry about which benchmarks are yours because none of them are yours. This could be a really wonderful thing to do. We have a paper about concurrency testing using schedule bounding, which was led by my former PhD student, who's actually one of my colleagues at Google, who I did the startup company with, Paul Thompson. And what happened here was Paul was looking at doing some work on concurrency testing, building on really great pieces of work like the Chess project from Microsoft Research, where you explore a concurrent program by running it again and again, taking control of the scheduler and exploring many different schedules. The problem with that work is that there are exponentially many schedules in the depth of the program and the number of threads. And there are these techniques called schedule bounding techniques that can allow you to prune the search space in a way that may nevertheless still allow you to find a lot of bugs. So there were a number of these schedule bounding techniques, and Paul was looking at ways to extend them or combine them with partial order reduction, which is another state space reduction technique. And what we found was there just wasn't a good set of benchmarks that was the obvious set of benchmarks to use. There were a whole load of papers, and those papers used a mishmash of benchmarks. Some of them used each other's benchmarks, but not usually every benchmark from one paper being used by another paper. Often there was like this paper used a subset of this paper's benchmarks and a subset of that paper's benchmarks. And it wasn't really clear from the claims in the papers which of these techniques worked the best. And that's because the papers were published by different authors in a, just in whatever sequence of order and time they happen to appear. So what Paul did was he actually got hold of all of the open source benchmarks he could find that could be used in a concurrency testing tool for C++ programs. And he implemented in an existing framework all of the schedule bounding algorithms that we'd read about. And we did an evaluation of all those algorithms across all those benchmarks. And we wrote up our findings with respect to the different algorithms and with respect to the different benchmarks. And a lovely thing here was that we didn't feel that we were trying to defend any particular idea or defend any particular set of benchmarks because we hadn't written any of them. They were all existing. So we were able to be, I think, very objective in our approach here. And the study led to some really interesting results. And we got really, I'd never submitted an empirical study before, and I wasn't sure what to expect, but we actually got very, like, what's the right word? The reviewers said, kudos to you for doing this study, more people should do this. And I was worried that they wouldn't have said that. I was worried they might have said, where's the big new idea? Why have you done this work? Why haven't you presented a new algorithm? But this actually went really well, and Paul got the best student paper award at that conference. And then we were invited to do a special issue where we did even more algorithms there. So this turned into, I think, probably although Paul then went on to do some other more novel stuff in his PhD, I would say that his chapter on concurrency testing was, in my opinion, the best chapter in his PhD work. Okay, so some pros and cons of an empirical study. As I mentioned before, it's very liberating because you don't have any corner you need to fight. You can go ahead and do a really rigorous evaluation of other people's work, and you're not promoting anything new or not defending any idea you've had. Again, like a survey, it can be a lot of work to do it well, and it can be a big service or disservice to the community if you do it well or poorly. And again, like a survey, it can end up being quite highly cited. Another thing that an empirical study can lead to is a standard set of benchmarks that other people can use. And that's a good contribution to your community. And B, it's also something you'll get recognition for. And let's face it, many of us do like recognition. I think we do care about having our names on our publications. And similarly, having your name associated with a standard benchmark suite can be a really nice thing. So I would encourage you to consider, if there's not a good set of benchmarks in your field, maybe you should collect what you can find, make a set of benchmarks, evaluate all the available techniques on those benchmarks, write a really nice paper about the evaluation that criticizes the tools and criticizes the benchmarks. And then in doing so, you'll probably end up with loads of good ideas of ways to take the field forward, and you'll know what's wrong with the benchmarks and can think about ways of making better benchmarks. Okay, and I won't spend much time on this slide, but a tutorial is something you might consider instead of a survey. So a survey tends to be encyclopedic, trying to go through all the papers in the field. A tutorial could actually be a way of saying, I've come to this field, I've understood some techniques, I'm going to write an article giving a tutorial about some of those techniques, even if I didn't write them. And some venues accept tutorial papers that don't need to be novel. In particular, some conferences accept Perl articles, which could be short articles that give an elegant take on a known problem, for instance. Not a very serious suggestion, not really a serious suggestion, is don't work in a crowded field. That's one way to cope with a crowded field. And you might want to think about that next time you bemoan machine learning from getting all this attention and programming languages not getting as much attention. But you know, actually, working in machine learning must be very difficult and stressful. There's work coming out all the time. I don't know how people keep on top of that work. People seem to be publishing papers like they've got a printing press in their corridor. And I don't know how you have time to write all those papers and also read all the papers other people are writing. So I'm very happy to be working on programming languages and compilers just for the sake of being able to have a little bit of peace and quiet to think about what I want to do and have some time to write it out well and get it published without everything changing in the meantime. Okay, so that's the end of that section, and I'd be keen to answer any questions that have arisen there and move on to another section otherwise.
There are a couple of questions, but they're quite general and broad. So I think it might be reasonable to go on to the next one in the remaining approximately 15 minutes we have, and then these questions would be great for the Slack discussion, or you can get to them at the end of the talk.
Sounds good. All right, what would you recommend next?
Great. The third most popular one is advancing on flawed prior work with 49%.
Okay, cool. So advancing on flawed prior work. What I mean here is you've entered a field, and it may not be very crowded yet, but you've got some really good ideas, and there's prior work that's kind of spoiled the field for you. So there's a phenomenon which I won't give its proper name to. You can choose what word you like here, but the something and run phenomenon, where this is a good strategy for quick academic success. What you do is you find a hot new area. So you find some area that you think is really interesting. You write one hype-filled novel paper that scratches the surface of the area. It definitely has some new ideas, but it doesn't go very far with those ideas. And you hype it up enough just to get it published at PLDI or ICSI or some top conference. And then you leave the area, and then you repeat the process. You find another area and you do the same thing to it. And what you end up with is a bunch of papers that are like the first paper in the area. Everyone cites them, and your name is on them, but you don't have to do the hard work of actually substantiating those ideas. So please don't do this. This spoils the research area for everyone who follows it, and can be a really damaging thing to do. And unfortunately, I do think that there are some research areas to which this has been done. I'm not going to give any examples in this part of the talk. I think there are cases where there can be a paper that everyone regards as the main paper with a certain idea in it, but the paper is hard to understand or doesn't go very far with the idea. And because of maybe the problems in our community of it being difficult to get corroborating work published, people then don't actually take that area forward. And this rather unsubstantiated, hype-filled first paper dominates, and yeah, we don't get the benefit of papers that might have followed it or a better version of it. So suppose that you're in this situation where you have actually ended up working in a field where someone has kind of damaged the field in this way. How can you nevertheless make your work shine? Okay, so let's talk about impenetrable prior work. So it might be that actually the paper that's causing you a problem, the prior work, is maybe just being done by people who aren't very good at writing or aren't very good at expressing themselves. And it might be that the paper is clearly relevant to your work, but it's so poorly written or so dense that you can't actually spell out quite what's the same and what's different from what you've done. You know that if that paper didn't exist, you could write a lovely paper that would be elegant and well written and other people could understand it really well. But you have to acknowledge this other paper, and you feel you've got to explain, as you should as an academic, what the differences are from this paper and your work, but you don't quite know how to explain those things. So how do you make your work stand out? It doesn't really seem adequate to say, we believe our approach is related to that paper, but we can't understand that paper well enough to articulate the differences. So what you can do here is a very candid comparison. If this is an experimental piece of work, say that you've built some tool and there's another paper about some other tool, and you can't really understand the theory behind that other tool, but the tool is available, then what you can do is compare the tools head to head. So you could demonstrate that the other tool is complementary to what you do, or maybe you could demonstrate that it's unsound while your approach is sound, or maybe that it's broken when your approach is not broken. And then you can say something better than what I had on the last slide. You can say, we're not sure what approach X claims to provide in principle, but our evaluation shows that in practice, it has these problems, or it does appear to have this good property. So you can give a kind of empirically backed argument for what you think that previous work intended to do, even if you can't fully understand the previous work. This, of course, relies on tool availability, which I think is why it's so important that we do go and make the artifacts from our research available after we get papers published, so that other people who may have trouble understanding our work can at least go and do evaluations against what we did. This is more difficult in theoretical work, because if someone has proved a theorem and you maybe don't quite understand the statement of their theorem because it's a bit ambiguous, it could be a bit more difficult to kind of criticize that theorem. Or maybe you're working in some program logic that's got a bunch of new features, and a good question from a reviewer might be, couldn't this all be done in this other program logic? If that other program logic is very difficult to understand, you may not know the answer, but what you could do is you could try to translate examples from one program logic into another, and then you could give instances where either it doesn't work, or it's incredibly difficult to do, or it's in your opinion, inelegant. I think that spelling out the differences on an example by example basis is a reasonable substitute for being able to articulate the differences in general. Another thing you can potentially do if you're in this problem of you think you've done something novel and you can't quite work out whether it's novel compared to some other approach is you can re-implement another approach and evaluate against it. This might be important if, for example, tools reported in previous work have not been made available, or maybe they are available, but they are not really directly comparable to what you've done. Maybe they work on different programming languages and there's no benchmarks you could actually use to do a head-to-head comparison. Then do consider re-implementing ideas as well as you can and doing a comparison. And I think if you do this, using the phrase best effort is a good thing here. You can say we made a best effort to compare against this prior work by re-implementing it as faithfully as we could, and then here are the results. And that, I think, is typically very much appreciated by people who review your work. Another thing you can do, and I would encourage you to do this, is contact the authors of prior work. So if their tool's not available, you can contact them and say, could you make your tool available? And if they do, then you can go and do a comparison. And if they don't, you can say they refused. If they don't reply, you can say we contacted them, but they did not reply to us. And as long as you do this and give them a bit of notice, if people won't give you their, if they won't give you access to their tools, or they won't do you the decency of responding, and you do bug them about it and make sure that the email didn't just get spam filtered, then you can just say that in your work. And I think that people reviewing your work may be very sympathetic to the fact that prior work that's mysterious and mysteriously unavailable is a problem that we often face in science, and we can't not let new work that is clear, is open, is publicly available flourish because of the supposed existence of this prior work that's written about but not made available.
Great. We have a question from Sebastian who asks about how would you balance between not spoiling a new area because the first paper won't go far enough and not hiding it from the rest of the world?
So you mean if you're the, I presume the question is if you're like if you're the person who's gone into the area and maybe made these contributions, and then you perhaps would like to get it published, but maybe you don't want to carry on. I think you can
I think this might be somebody trying to follow your suggestion of, as Emery called it in the Slack channel, not licking the cookie.
Right.
So how do you make sure you're not doing that?
So yeah, I think that, well, there are two things. So first of all, if you've got into a new area and done some work that you think is novel, but you don't want to carry it on, then the best thing you can do for the community is do publish it, but be really clear about the deficiencies of what you've done and be really clear about where people could do follow-up work. And that way you're giving people that follow you all the hooks they need to write their related work section where they say, so-and-so did this work, but as they acknowledge, it's weak in these regards. And then they don't have to feel like they're, well, yeah, you're kind of giving the people that follow you the ammunition they need in a positive way. I guess if I didn't quite understand the question, if it relates to the field having been slightly wrecked and what you do to follow it. What was your interpretation of that again, Stephen?
My understanding of the question was the one you just answered, that if you are the first one in the area, how do you, and like you say, how do you balance between not spoiling the area for people, for others, like you mentioned, yet also getting it out there? I think your answer was great. To be honest and acknowledge the shortcomings of what you've done and the areas left to be, and the future work that perhaps is left to be done.
Right. And I think as reviewers of papers, we could also be really sympathetic to and grateful when authors are honest. So I think it's actually tempting as a reviewer to maybe unconsciously hope for good news and want to be able to champion a paper because it appears to have no limitations. Of course, all papers, all research has limitations. And actually, I think we should celebrate when authors are actually brave and honest enough just to spell out what the limitations are. I don't mean litter your whole paper with self-deprecating claims about the limitations of your work, but I think being pretty clear at the beginning what you do achieve and what you don't achieve can make the work not only easier to understand, but also easier for other people to follow. Okay, I don't know how we're doing for time.
Right, well, we have just a few minutes left, given that the talk started at about 1:15. There's a couple of specific questions that maybe we can get to. One is, I feel like proposing a new programming language is met with a lot of skepticism unless you have a very strong justification for creating it. Is that the case? If so, what to do?
I think that probably is the case. I mean, there are a whole load of programming languages, and making a new one isn't necessarily very helpful, it could be very hard to do anything in terms of a comparison with anything else if you made a new language and it's nothing you can compare it with. I think that it may well be that there's an idea you want to explore that could easily be embedded into an existing language as an extension, or maybe as a language-like library. So where you effectively extend a language with new commands by making a library that could be interpreted as language extensions. But they're making a brand new language. Yeah, I think there really has to be a compelling reason to do that. And if there is a compelling reason, then it's your job to spell that reason out. And I would say, if you really believe in it, be brave about it and do it. And do expect resistance, and don't get too grumpy when your first few papers get rejected. It may take you a bit of time to convince people about the benefits. And hopefully, even though it can be a bit slow, hopefully the peer review feedback loop will end up leading you to converge on a better way to explain what you're doing. But yeah, that can be a difficult one.
Okay, thanks. Let's do one last question before wrapping up.
Yeah, I have a couple of end slides as well, which I'll maybe skip to, but yeah.
In that case, let me ask the one question, which should just, oh goodness, questions coming in. Following up on different communities, the work might be more well received in principle in another community, but you might not speak their language. So how do you balance that? Your suggestion of try and find the right community.
You just have to read papers from that community and learn their language.
Fair enough. Thanks. So, Ali, please wrap up. There are some more questions, but we can continue those discussions in Slack, given that we won't get to them.
So yeah, I think the final thing I wanted to talk about was, and it was raised earlier, novelty versus impact. So I want to just mention two tools in programming languages that I think are really great. One is CLE, which came from Stanford, and now Christian Cadau, who's the main maintainer of CLE, is one of my colleagues at Imperial College London. Another tool is CBMC, a bounded model checker for C programs. These are both examples of tools that have had a massive impact and have led to a ton of follow-on research. They've been platforms for other researchers to build on, and they've in some cases led to company creation. And actually, in the case of CLE, there's this ICSI paper that studies 50 projects that themselves build on CLE. So actually, these tools, while the papers that introduce them do have significant novelty, they're actually tools that have then had years of engineering pumped into them to keep them alive and to make them available to the community. But I would say that those tools have a much higher reputation for the creators and a much more of a contribution for the community than any paper I can think of that presents some new idea. So I think actually you can have a lot of impact by doing the engineering work required to really get things working than you will have if you just do a stream of papers, each with some new idea that is nice for the reviewers of a top programming language conference to champion. And something that I've done that's been high impact for me, and I'm not claiming that the impact of this has been anything like the impact of CLE and CBMC, but is the graphics fuzz project that I mentioned before, which I would say is among my least novel pieces of work. I told you the story of it, how I was inspired by this other compiler testing work. I wanted to try that stuff out myself and did a comparison with of those techniques in another domain. It ended up being a lot of fun. It ended up really working well, and it led to some exciting adventures we're now having at Google as a result of going that route. So to conclude, what I'd say is, if novelty is flowing in your work, then enjoy it. But if novelty is not flowing, then you could take comfort. Some of your least novel work might be work that changes the world. So don't despair. And I'll leave you with this quote from Peter O'Hearn. I'm of the opinion that academic computer science estimates the significance of novelty maybe a little too much. From an industrial perspective, we would have more to go on if there were more corroboration and less uncorroborated novelty. That's from an interview that Peter did with PL Enthusiast that I'd encourage you to go and read. So thanks for listening. Thanks for all the questions. If we have time for any more, I can answer them now. Otherwise, I'd be keen to follow up on stuff.
Great. Thanks so much, Ali. That was a really great talk. Interesting, insightful, and really practical, concrete suggestions. Thanks. We maintained the viewership of about 340, 350 viewers. So a lot of interest out there in this, and indeed requests if you're willing to share the slides on the PLDI Slack.
Good, sure.
So, thank you so much.
All right. Thank you very much. Enjoy the rest of PLMW and PLDI. Cheers.
Thanks. So this wraps up the first session for PLMW. We're going to be back at 1 p.m. Eastern, so that's in approximately 45 minutes, for session 2 of PLMW. It's going to be the same YouTube link, so that is the same live stream that you're viewing. It will, however, be a different Slido link, and the Slido link for session 2 is linked to, again, underneath the video in the description. So thank you very much for attending session 1. Look forward to seeing you soon for session 2.
I'm going to stop the stream for a little while if you're watching on the stream, but we'll be back at around 1 p.m. Eastern.